Hey guys, this is lesson 12.4, compound events, and this is your last lesson for the year. So get out your notes and get ready to take your last notes of your 7th grade year. So today we're going to talk about independent events. So let's say we want to talk first about the independent events, and really the only thing that you need to copy down in your notes is this information right here. But this at the top is just an example of an independent event. Suppose the numbers from 1 to 10 are written on 10 cards. One number to a card. You are interested in drawing one card at random and getting an even number. Then drawing a second card and getting an even number again. When you replace the first card, so when you replace the first card, the probability of getting an even number on the second card is unaffected. So when you replace something, that's an independent event, because independent events are events for which the occurrence of one event does not affect the probability of the occurrence of the other event. So if you were to draw a card out like in this example, and you draw it out at random, you would have a 5 in 10 chance of picking an even number, because you could pick 2, 4, 6, 8, or 10. Once you pick that card, if you put it back into the pile and mix them up again and pick them out again, you still have the chance of picking 2, 4, 6, 8, or 10. So the probability the second time of drawing an even number is 5 out of 10, which both of those are 1/2. And in the multiplication, or the probability of independent events, you multiply the probabilities together. So the probability of drawing an even number the first time is 1/2, and drawing an even number a second time is 1/2, and then when you multiply that together, the probability of drawing 2 even numbers on the cards would be 1/4. So let's look at another example. You roll a number cube, which is a die, and then you roll it again. What is the probability that you get a 2 on the first roll? So we want a probability of 2. And then, and then a number greater than 4 on the second roll. So then you want a probability of greater than 4. So on a number cube, we know that there are 6 sides. So the probability of rolling a 2 is 1 out of 6. The probability of rolling a number greater than 4, that means we can only roll 5 or 6. So that probability is going to be 2 out of 6. Now remember, the probability of independent events, we multiply the two probabilities together. So the probability of rolling only a 2 is 1/6, and the probability of rolling a number greater than 4 is 2/6, which actually we can reduce that to 1/3, because we can divide each of these by 2. So we have 1/6 times 1/3, which would be 1/18. So we have a 1 in 18 chance of rolling a 2 and then a number greater than 4. Now the second problems that we're going to talk about are the probability of dependent events. And what that means is that events for which the occurrence of one event is going to affect the probability of the other event happening. So let's look at this again. Just copy this information down here in your notes. But let's look at this example here. Suppose you want to draw 2 even numbered cards from cards showing the numbers 1 through 10. You draw one card, then without replacing. So that makes it dependent, because you're not replacing that card. So the first card you draw, and then the second card you draw, the probability is going to be different. So if we draw the first card and we want to get an even number, we have a 5 out of 10 chance, which would be equal to 1/2. Now we're not going to replace that card back in the deck that we drew out. So then we only have a 4 out of 10, or excuse me, 4 out of 9 chance of getting an even number. So then we multiply those two together, 1/2. And we only have 4 out of 9 because there's only 4 even numbers and there's only 9 cards left now. So when we multiply that together, we get 4/18, which actually we can divide by 2. And that reduces to 2/9. So we have a 2 in 9 chance of drawing an even card the first time and then not replacing it and getting an even card the second time. So let's look at this example. 3 girls and 2 boys volunteer to represent their class at a school assembly. So this is important here. We have 3 girls and we have 2 boys. The teacher selects one name and then another from a bag containing the 5 students' names. What is the probability that both representatives will be girls? So we want the probability of a girl, and we're going to multiply it by the probability of a girl. Now remember, we're not going to put the first person's name back in the bag. So the probability that we're going to draw for the girl the first time is 3 out of 5. So now the next time we draw, assuming that we draw a girl, there's only going to be 4 names left in the bag, and we'll have a 2 out of 4 chance. So when we multiply that, we get 6 out of 20, and that can be reduced. We can divide by 2, which would make it 3 out of 10. So you have a 3 in 10 chance, or a 30% chance of drawing 2 girls. That is it for today. Make sure you come to class with any questions that you have.